So let's get rowdy, let's make some noise, and help me to welcome our next speaker, Jeffery Gold.
Thank you, Ray. Woo! So, warning. 3. So, my name is Jeff Gold. I work here at OHSU. And what I'm going to be doing today is talking to you about how we're using simulation to improve the use and safety of electronic health records. All right, most of you are probably aware, title slide, there we go. Most of you are probably aware that electronic health records are part of the Affordable Care Act. Their use is being incentivized as part of that, so their growth has expanded exponentially over the last few years. As you'll see on the following slide, when it does come up, is that growth has increased of electronic health records by over 50% over the last 8 years, and it's continuing to grow. But what we've learned about this is that while they're supposed to make things safer, there have been multiple unintended consequences to their implementation, and safety has been but a wash. There are a lot of reasons for this. One is data fragmentation. This is from our study. One patient, 10 minutes of looking through the record, 20 individual screens, 40 total screens. All those screens mean lots of data. If you look at your typical ICU patient, the average ICU patient will have between 1,400 and 2,000 data points entered per day per patient in the ICU. Now, one of the things EHRs are supposed to do is make things safer by alerting you to abnormal data. What you're going to see here is a screenshot from a patient, a typical patient in the OHSU ICU. This is just their lab data. Everything's abnormal. You tell me which alert you should pay attention to. And what I'll tell you is that the average subject in our ICU, 40 alerts per day, just from labs alone. Now, what does this all lead to? Cognitive errors. This is a screenshot from one of our patients who unfortunately died, a 22-year-old girl. The very top row are the blood pressure readings there. You can see them, 115/48. None of them are red. They all look normal. But if you take this tabular view and put it into a graph, one of the predefined graphs in our electronic health record, what do you see? Look at the third row down, the gray. You may start to see that number start to go down just a little bit. But you know what? It's still not that apparent. But if you make a customized graph in our electronic health record, which no one teaches you how to do, by the way, you'll see that, look at that purple line. Look at the blue line. This unfortunate girl had 36 hours of missed hemodynamic change, had a cardiac arrest on the floor, and died. So how are we going to fix this problem? We're going to be using simulation. And what is simulation? Simulation is high-stakes training in a low-risk environment. This is what you do for ACLS. This is the flight simulator. So what did we do? We created fake patients in our electronic health record, and those fake patients are complex. They have days' worth of data, and they have built-in errors. They have built-in changes in the patient condition. Our residents, when they're on service in the ICU, are given 10 minutes to review the case. So real-life workflow. They have to then present the plan, and they're graded on how many of the errors that they picked up. Now, this isn't done that often. As far as I know, we're the only ones doing it. What we find? We suck. So the average person picks up less than half of the errors within a case. Even our fellows, the best ones, are at 50%. Our interns at 30%. What's even worse is that there's no consistency to our suckiness. We miss everything equally across the board. So it's not like we're good in some areas and bad in others so that we can focus our education. Everyone's learned their own bad habits. But what I can tell you is that we've now created additional cases. So now our people go through the testing twice. Once, and then again a few weeks later with a completely different case. Case 1, case 2. If you go through it the second time around, if you're going through case 1, you do better than the first time people who hit case 1. Same with case 2. What's even better is if you looked on a paired analysis. So you could see, does an individual get better? The answer is yes. All the little dots either stay the same or go up. So again, it's a valuable teaching tool. But you know what? We're nowhere near 100%. Why? I don't know. But part of it is trying to figure that out. So now we are using eye tracking technology to understand where are they looking in the chart. Because it's not just using the electronic health record. What did you see? This is our setup. You can see the eye tracker bar right below the screen there. And what does it give you? It gives you a readout just like that. So here's a screenshot from an electronic health record. We can see exactly where the people are looking. We've created a composite score based on how many times they look at any of the action items or errors within this case. What's nice is that this composite score, as you'll see on the y-axis, correlates quite nicely with how many of the errors they actually verbalize as seen on the x-axis. So we can actually tell what they're looking at. But the bad thing is, as we've also learned, is that fragmentation is a necessary evil the way our EHR is designed. So what we could see is that the number of unique individual screens correlates quite nicely with your performance, meaning you have to look at more and more screens just to get the answer in the case. What's even worse is that the physicians have to do more work. We see the exact same thing with the number of mouse clicks. The average person, this does correlate, believe it or not, but that number of mouse clicks is between 80 and 90 mouse clicks. This is in 10 minutes. And imagine if you're rounding on 6 to 10 patients a day. So, in conclusion, what I'd like to tell you is that we've used simulation to demonstrate the blind spots in our electronic health record. More importantly, this is providing a novel and high fidelity and fun educational tool, and that by using devices like eye trackers, we can help inform usability and EHR redesign. Thank you.